Hello everyone, hope you all are doing well. So today we are going to do the next question of our agriculture optional आंसर राइटिंग प्रैक्टिस सीरीज जो हमारी एग्रीकल्चर ऑप्शनल आंसर राइटिंग प्रैक्टिस सीरीज चल रही है उसके नेक्स्ट क्वेश्चन को आज हम लोग करने वाले हैं. एंड टुडेस क्वेश्चन इज व्हाट इज इम्बिबिशन एंड differentiate between osmosis and diffusion. So this question was asked in the Indian Forest Service examination which is conducted by UPSC. जो UPSC के इंडियन फॉरेस्ट सर्विस एग्जामिनेशन होता है उसके एग्रीकल्चर ऑप्शनल पेपर में ये क्वेश्चन पूछा जा चुका है. So it becomes important for us. So let's see how we can approach the answer. So as we know the question is divided into two parts. First part is what is imbibition and second part is differentiate between osmosis and diffusion. So we will be doing the first part first. So what is imbibition? So it is a process of the process of absorption of water by solid substances. It is the process of absorption of water by solid substances. Absorption of water by solid substances through their surfaces. So what is imbibition? When solid substances absorb water through their surfaces, that is what we call that imbibition. That is solid substances. It is the key point here, keyword here. When solid substances absorb water or moisture. So for example, you can give up here such as swelling of seeds in soil. When we put in the soil, seeds get swell up. That is, they absorb the moisture. Swelling of seeds, swelling of wood logs, swelling of wood logs. Sometimes we see that whenever wood logs get contact with the moisture, they get swelled up, they get swell up. So that is what imbibition is. So this is the a good definition and you can use it. Now let's move to the second part of the question, that is differentiate between osmosis and diffusion. So let's differentiate both the terms. First of all, we will write osmosis this side and diffusion this side. So osmosis involves the movement of solvent from movement of solvent from from a lower concentration of solute to a lower concentration of solute to a higher concentration of solute to a higher concentration of solute. So this is the basic definition of osmosis. And what happens in diffusion is that it involves the movement of molecules from a higher concentration of solute to lower concentration of solute. Just opposite, movement of molecules from higher concentration of solute to lower concentration of solute. So I hope you understand. In osmosis, the movement is from lower concentration to higher concentration, and in diffusion, the movement is from higher to lower. In osmosis, the movement is from lower to higher, and in diffusion, it is from higher to lower. So this is the basic difference. We will see more differences. Osmosis is limited to the liquid medium only. Liquid medium only, whereas diffusion occurs in all mediums. It occurs in all mediums, either it be liquid, either it be solid, or either it be gas. Moving to the next point, this side is osmosis and this side is diffusion. Moving to the next point, osmosis requires a semi-permeable membrane. It requires a semi-permeable membrane, while diffusion do not require a semi-permeable membrane. Not required. In diffusion, the semi-permeable membrane is not required. So it is another difference. In osmosis, it requires water for the movement of particles. It requires water for movement of particles. And in diffusion, there is no ultimate requirement of water. It can happen with water or without water. So not necessarily required. Okay. So this is the another difference. Next, in osmosis, only the solvent molecules can diffuse. In osmosis, only only the solvent molecule can diffuse. But in diffusion, both molecules of solute and solvent can diffuse. Here, both molecules of solvent and solute can diffuse. In osmosis, the flow of particles is only in one direction. Osmosis is unidirectional. Here, in diffusion, the flow of particles can be more than one direction, in multi-direction. So it is a multi-directional movement. Multi-directional. Moving on. Osmosis generally occurs in similar types of solutions. Occurs in similar type of solutions, whereas diffusion occurs between both similar and dissimilar types. Both similar and dissimilar types. Both similar and dissimilar types. In osmosis, the process can be either be stopped or reversed applying pressure on solution side. It can be either be stopped. This is osmosis and this side is diffusion. In osmosis, the process can be stopped or reversed using pressure, or you can say applying pressure on solution side. But in diffusion, we can't, neither we can reverse nor we can stop. Neither can be reversed nor can be stopped. So this is another difference. The concentration of solvent does not become equal on both sides of membrane in osmosis. Concentration doesn't become equal on both sides of membrane in osmosis. And in diffusion, the concentration of diffusion substance equalizes to fill the available space. Here, the concentration of diffusion substance equalizes to fill the spaces. So these were some of the basic points of difference between osmosis and diffusion, and I think these are very simple points. Nothing some rocket science to explain that much in detail, and I hope you understand all the points. You can add more points also. अगर आप चाहो तो इसमें और भी points add कर सकते हो if you want. बट विच एवर न्यू पॉइंट यू आर एडिंग प्लीज लेट अस नो बाय कमेंटिंग. कमेंट करके जो भी आप नए पॉइंट्स ऐड कर रहे हो हमें जरूर बताओ, so that we also get to know that you are adding fair points or not, you are going in good direction or not. So that will be also helpful to you. So I hope you understand both imbibition, osmosis and diffusion. Every term is well understood by you. So that is all for today. If you like it, please do like, please do share, and please do subscribe. It takes a lot of hard work to make such videos for you on रेगुलर बेसिस ऐसे वीडियोस को बनाने के लिए काफी हार्ड वर्क लगता है. और अगर आप लाइक करते हो, शेयर करते हो, सब्सक्राइब करते हो, तो इट मोटिवेट्स अस टू मेक मोर सच वीडियोस फॉर यू रेगुलरली. So that is all for today. Have a nice day. Thank you.